Number 5 on the first page. Okay. All right, number 5 on the first page. We have y equals 4x plus 11. And we have negative 3x plus 4y equals 18. Okay, so we're not graphing this one, right? We are doing substitution. So the very top equation, we have this, and I'm going to replace that for right there. So if we have x equals or y equals, we can take whatever it's equal to and replace it. So on this equation, I'm going to get this. Is that okay so far? Good. Distribute over the parentheses. And these are like terms, so I'm going to go ahead and combine those first. That's an 18. Subtract 44. So 13x is equal to, what is 44 minus 18? It'll be negative, I know that. And that's going to be 36. Cool. Divide each side by 13. Those cancel, so x is going to give me negative 3. Okay, so that's my first answer. That is an x value. So I can take that x value and plug it in here or here. It'll give me the same exact answer on both. I think the top one's better to plug it into because we're looking for a y value. What else did you see on the homework, friends? Feel good? Feel bad? Different? Good? Okay. No more questions going once. No more questions going twice. All right, so let's get the notes out from last time. And we're a couple pages into that, so it'll be like third page or somewhere in that, and the one I gave you just, Josh. All right, so real quick on the warm-up, we want to solve it. So I have y equals or I have x equals. So I'm going to take this and I'm going to plug it in right there. This right here had been a y, but I plugged in 2x plus 2 in place of it. Distribute the negative over. Combine our like terms. Add 2x to both sides. That gives me 3x is equal to 3. Divide by 3, divide by 3. X equals 1. So we know an x value, so I can take the x and plug it in there or there. The top one seems like it's already set up because we're looking for y. Is that it? Cool. For problem number 2, we have to modify this top one a little bit. I'm going to make this y equals 2 minus 2x. So what did I just do that I didn't show the word?
You subtracted x from both sides.
Yeah, I subtract my x value. I wanted to get to y equals. And so I saw I had a singleton y in there. So I had to figure out, could I solve for one of the letters easily? And so on the top one, yes, I could have subtracted 2x from both sides to make it work. So once I do that, I know that my y value is this. I'm going to plug it in right there. This had been y, but now I'm going to put 2 minus 2x in there. Distribute the negative over the parentheses. Combine like terms. Add 2. Negative 3x equals 6. So x equals negative 2. Sweet. Got my first answer. So I'm going to take this negative 2, and I'm going to plug it in either here, or I'm going to plug it into here, or I'm going to plug it into here. And I think it plugs in easier here because I'm looking for a y value. That's 2 plus 4. So that gives me 6. Okay. I feel pretty good about it. Okay, substitution. You take part of one and put it into the other. Now let's take a look at where we're going to go from there. Is there any questions what I just did on the warm-up? Again, if you ever have questions, the video will be up and loaded. You can scroll to whatever. So we took care of graphing. We talked about some of the problems graphing has. Graphing, if you had fractional amounts for answers, it's hard to graph that. Graphing also doesn't have to cross on the graph that we give. It could cross at like 150, 370. Okay, and that's really hard to graph because it's way off your thing. Substitution seems to be a really good one. Substitution, where it has its downfall is if you can't solve for a letter easy. Okay, so what that means is if your equation, when you're looking at your two equations, if one of the two equations doesn't have an x or an x where there's not a number in front of it, or a y not in front of it, where meaning it's harder to solve, substitution has some hiccups. So then elimination becomes the next one we want to use. And elimination works nicely when you have the x and the y on the same side, and you just can combine your two equations together. Okay, so let's see what that means. Okay, so take a look at these two equations. Now, I could do substitution pretty easily because I can get my y by itself on the top by subtracting 2x. Agreed? But because we made it a simpler problem, take a look at this. First thing you want to look at when you are doing it by elimination, you want your x and y's to be lined up. Are my x and y's lined up how they're set up? Okay. Do I have, what would happen if I added these two equations together? Would I get this? Would that happen? Yeah. And if that happens, then this takes place. Those cancel. Sweet. There's my first answer. So then I'm going to take my answer, this negative 2, and I'm going to plug it in either here or here. Now this one, doesn't really matter which one we pick because they're both, we have a little bit of work. So I'll pick the top equation to plug it into. This is where x used to live, but x is now equal to negative 2. Okay, x is equal to negative 2. So then I'm going to get negative 4 plus y is equal to 2. Add 4. So elimination is the next version of this. Okay, and it's another way of thinking. It's another way of thinking. Amber, did you have the homeworks?
No, but I think it's going to change the pages.
Love it. Thank you. And remind me you came in so I can unmark you on my computer because I'm recording. I marked it on here, but I might forget, and it's not because I dislike you. It's because I'm absent-minded. Is that okay? Thank you. And we're just kind of going along. Remember that packet of notes I gave you? There's it's on the back end of it. If you need it, if you didn't bring it, you can grab a piece of paper here. Okay, so my friends, here's our next problem. So this is set up nicely for us as well. Our x's and our y's are in columns to each other. Agree? Hey, can I add my two equations together and one of the letters goes bye-bye? Yeah. If I add the equations together, my y values are gone now. So that gives me 8x. Those cancel, equals, what is that, 16? And then divide by 8, divide by 8. So x is equal to 2. So there's my first answer. So I'm going to take this x value and I'm going to plug it in either here or here. I don't know which one's simpler. They're both going to give me the same answer. So maybe I'll choose the bottom one. So I'm going to get 3 parentheses plus 6y equals 48. This was x, but I know that x is 2 now. I'm going to plug that in. Subtract 6, 6y equals 42. Divide by 6, divide by 6. Y equals 7. Ta-da. That definitely would not be one I would run a graph, because if you cover method, you covered the y, you'd get x equals negative 32 over 5. Good luck finding exactly where that is on a graph. Okay? You might get close. Maybe if you're not big enough, they might incorporate it, but it might be tough to graph. Can I move on? So I guess I 2, 7. Okay, we good? Okay. Question 1, are they lined up in columns? Can I add the two together and have a letter go away? I can. That gives me 8x, the y's cancel, equals 8. Divide by 8, so x equals 1. I'm going to take my x value, and I'm going to plug that x value either here or here. Doesn't matter which one you choose. I might choose the bottom one. So I'm going to plug 1 in here, so I get 6 plus 5y equals negative 9. Divide by 5, divide by 5. Y equals negative 3. Cool. It looks like it might be a little tiny bit less work. But we have to make sure my x's and my y's are lining up. Next problem. If I add the two, are the x's and y's all lined up as columns? Yeah. Can I add them together and something goes away? Yeah. If I add them together, x is gone. So I get 3y equal to negative 6. Take that y value, plug it in here or here. It doesn't matter which one. I'll plug it in the bottom. Minus 2 is negative 16. Add 2. Negative 7x equals negative 14. Divide by negative 7. That works really nicely. But we have to make sure that the x's and the y's are lined up before we do anything. May I move forward, my friends? Okay, now, are my x's and y's lined up in columns? Can I add the two equations together right now and one of the letters goes away? No, I get 4x plus 12y. Oh, things changed a little bit. Okay, so now the next thing I always kind of think in my mind is, could I, or do I have a opposite, my multiply is right. Do I have on top and bottom a positive and a negative x or a positive and negative y? Are the y's opposite sign? Yeah. So what I'm going to do is I'm going to take what you said with multiply. So I have opposite signs. I have positive, negative. And I'm going to say this. I'm going to multiply this whole thing by 5. So I'm going to distribute it. I'm going to move this one straight over. Now I'm going to go back to my original question. Are my x's and my y's still lined up? Yes. Can I add those two new equations together to eliminate one of my letters? Yeah. So if I add these together, I'm going to get 12x. Those cancel, equals 132. Divide by 12. Just because I'm a math geek, I know it's 11. I've only taught this for 26 years, so I finally kind of clicked. But you go 132 divided by 12, you get 11. Okay, so I get an x value of 11. So I'm going to take that 11, and I'm going to plug it into anywhere I had an x and a y, including the originals. So I might choose, take this and plug it in here or here. I think the bottom original one might be good. Done. Hey, that's a great one that wouldn't work on graphing, because my graphs I normally give you all go from -10 to +10, and 11 is bigger than 10. Does that make sense? Plus, I would not want to do the cover method with that. Yeesh. All right. Item 1. Are my x and y's lined up? Can I add the two equations together to have one of the letters go away? No. So, do I have an opposite x or y value as far as positive and negative? No. Okay. Maybe I could pick the entire bottom one and multiply it by a -4. And that's going to give me, this would come out to be -20x minus 4y equals positive 28. Now, if I add these together, I'm going to get 2x added to -20x, which is -18x. The 4y's cancel out. 8 added to 28 is 36. Divide by -18. X equals -2. I'm going to take that -2. I'm going to plug it in here or here. Doesn't matter which one. I'll pick this one. So that was an x. I'm going to put -2 in there. Add 4 to both sides. Divide by 4. -2/3. Ooh. This one right here?
No, top that you multiply to -4.
Oh, I looked and I said, hey, let's eliminate the y's. So if I pick the x's, I'd have to multiply both equations by something to get them to become the same number but opposite sign. On this one, if I multiply by a -4, I have a positive 4y. If that becomes a -4y, if I add this and this together, they're going to go away. So you kind of have to do a little detective work on it sometimes. Okay? Last problem. Last problem, friends. Last problem. It happens. Last problem. Are my x's and my y's lined up? Yes. Can I add the two equations together as they sit and have one of my letters go away? No. Do I have opposite x values or opposite y values? One positive, one negative on x? No. One positive, one negative on the y? No. So, Josh, This is where the -4 came from. On this one, I think I'm going to get rid of y. Okay? I'm going to get rid of y. So I'm going to multiply this whole top one by -2. And that's going to give me 6x minus 2y equals 2. This bottom equation, I'm going to write right underneath it. Add those, I get x equals 7. Oh, that's great. So I get 7. I'm going to take this 7, plug it into either here or here. Doesn't matter which one. I'll pick this top one. This was an x. I'm going to put a 7 in. Add 21. Definitely would be a bad one to graph, because 23 would be way off our graph, the ones I would give you. Okay? Questions, friends? I gave you a new opportunity. Agreed? Something different. So let's do this. So on here, this is in week 2. In week 2, this will be now due. There's only one page, yes? Okay, so I'll change this due date. This will be due on Tuesday next week, or Wednesday if they're watching the video and they're in the other group. Okay, you guys aren't the Wednesday group. So that'll be what we do. Okay, I'll put the link there. Okay, so SSLE number 5. If you still have the old book, grab that sheet out and do it. If you don't have the old book, grab this. Have it find it. Let Schoology think for a couple seconds. Maybe more than a couple seconds. You can print this off if you want, or you can just write down the problems and then show me on a separate sheet of paper. Feel all right? Everyone happy? Okay, so my friends, we have a huge quiz right now. Huge. Okay? You can use whatever notes you have on this quiz. Now, I'm going to warn you. Let me go back to this. I'm going to stop share here. So everyone, so I'll share here. I go here, share. Okay, so homework is SSLE number 5. Okay, you can find it on Schoology if you don't have it. So this will be due on Tuesday for this group, Wednesday if you're in cohort B. Okay, so you guys are worried about this. Okay, on this quiz, problem number 1 is a graphing question. Okay, but I'm going to warn you, when the 2 lines cross, this does not become an exact, this is not an exact value. It's not like 2,3. So what should you do? What do you think you should do if it didn't come out exact? I would use substitution. So go ahead and graph it, and you're going to get it where it crosses, and it's not going to happen exactly. So have the graph there, but then off to the side, there's room to the side to maybe do substitution. Okay? You might be able to graph good enough, but if it's a fraction, it's really hard to get the exact value when just looking at your picture. So that's my warning. Okay? We good? We happy? Everyone know what to do for Tuesday? Everybody ready for a quiz? If you have a calculator, you can use a calculator. I don't think you need one, but you're allowed to. And I'll allow you to use that packet of notes on it. Not homework, notes. Cool? We good? All right, I'm going to stop recording.